This speech is my recital. I think it's very vital to rock around. That's right. On time. It's tricky. It's the tight. Here we go. It's tricky to rock around. To rock around. That's right. On time. It's tricky. It's tricky.
Cloning has been a question for the human race for a very long time. However, as time moves, so does our idea of what it is and what it should be. The classic Hollywood idea of cloning, along with that of books and television, influence humans to associate specific feelings or images with the process. Often, these ideas of clones can be brainless monsters or identity thieves, and they are a very popular belief in the majority of moviegoers, or anybody who has read such a book. Once these ideas are made accurate in the eyes of the public, we can work to make sure cloning is properly understood for its real dangers and benefits. It is first appropriate to examine the true definition of cloning in order to understand it. The term cloning describes a number of different processes that can be used to produce genetically identical copies of a biological entity. The copied material, which has the same genetic makeup as the original, is referred to as a clone. Legally, there are no federal laws regulating human clones in the United States. However, there are laws and policies restricting the federal government from funding human cloning research. However, there are state laws passed on human cloning. For example, 7 states, including Virginia, prohibit both cloning to produce children and cloning for biomedical research. Cloning is performed in 2 ways in a lab so far: artificial embryo twinning and somatic cell nuclear transfer, or SCNT. Artificial embryo twinning is a relatively low-tech way to make clones. As the name suggests, this technique mimics the natural process that creates identical twins. In nature, twins form very early in development when the embryo splits in 2. Twinning happens in the first days after egg and sperm join, while the embryo is made of just a small number of unspecialized cells. Each half of the embryo continues dividing on its own, ultimately developing into separate, complete individuals. Since they develop from the same fertilized egg, the resulting individuals are genetically identical. Artificial embryo twinning uses the same approach but is carried out in a petri dish instead of inside the mother. A very early embryo is separated into individual cells, which are allowed to divide and develop for a short time in the petri dish. The embryos are then placed into a surrogate mother where they finish developing. Again, since all the embryos came from the same fertilized egg, they are genetically identical. SCNT, also called nuclear transfer plainly, uses a different approach than artificial embryo twinning, but it produces the same result: an exact genetic copy or clone of an individual. In SCNT, the nucleus, which contains the organism's DNA, of a somatic cell, a body cell other than a sperm or egg cell, is removed and the rest of the cell discarded. At the same time, the nucleus of an egg cell is removed. The nucleus of the somatic cell is then inserted into the enucleated egg. After being inserted into the egg, the somatic cell nucleus is reprogrammed by the host cell. The egg, now containing the nucleus of a somatic cell, is stimulated with a shock and will begin to divide. After many mitotic divisions in culture, this single cell forms a blastocyst, an early stage embryo with about 100 cells, with almost identical DNA to the original organism. In the great debate of cloning and its implications upon our society, many cases have been made for cloning that are of great interest. One is that of reproductive liberty, meaning that cloning would be the only possible way for a couple to have a genetic offspring due to infertility. Therefore, providing cloning as an option contributes to the greater scope of procreative liberty. For example, the male partner relationship may be unable to produce viable sperm, and instead of speaking a sperm donor, the couple can choose to use SCNT in order to produce a genetic copy of the prospective father. While cloning may appear to have many benefits and offer advancements to science and society, there are many factors which could rule out cloning as a viable option in the future. For example, the right to a unique genetic identity. Because cloning entails recreating an existing person's genetic code, some argue that cloning would necessarily entail a violation of the cloned child's right to distinctive genetic identity. According to this objection, our DNAs would endow each human being with uniqueness and dignity. Because cloning recreates a pre-existing DNA sequence, the cloned child would be denied that uniqueness, and therefore their dignity would be compromised. This objection is an incarnation of the objection from the right to an open future. Certainly the concerns are similar, that a cloned child would be deprived of their own individual identity because of their genetic origins. Personally, I certainly see and understand both sides of the cloning argument. After completing my research and reading far more in depth on the topic than I have before, though, I find that cloning, while it may need certain limitations to protect certain inalienable rights, should be allowed to proceed. A very frequent argument against cloning I have come across states that it would decimate the right to a unique genetic identity, but I do not think this is the case. A cloned child in this scenario would be raised in a different environment. They would be born into either the same family but with a different dynamic as their genetic predecessor. They would also likely be raised in a much different society. For example, a child born in 2010 would have vastly different social influences than a child born in the 1960s or 70s, as suggested by studies then and now. What forms or shapes each person's individual identity is an intricate interaction of genetics and nurture. Thusly, I feel that with certain limitations, cloning should proceed.
It's tricky, 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 tricky. It's tricky to rock around, to rock around.
Oh yeah. Today we're going to talk about the importance of cloning. Beast from the Middle East. You know what we're about to do. It's going to be real. It's going to be fire. Oh yeah. Alright, let's get started. Mama. You know me, the beast, the straight fire Muslim from the Middle East. Let me hit you up with this story about how I was cloned in a laboratory. Cloning is a process which can do a lot of good. And did I let you know that I came from the hood? First, let's do the definition. We're talking SCNT. Quickly means we put somatic cell in some other cell, which divides into a new blastocyst. Now we have an identical homie rocking out nice. Yeah. Let me get a quick shout out to the homie Dolly, first mammal that had no folly and was cloned pretty close to perfect. So make sure you show her some respect. Now that we talk specifics, it's time to get prolific. Pros and cons, man. It's off the wall, man. It would help prevent disease as preached by Socrates. But include this in your analyses. Genetic identity may be at risk. It all depends on how brisk we can make these advances safely. The future of cloning may be up in the air, but this real brown homie says to prepare, cause the future can aid our welfare. But we have to stay safe, so take care. Yeah. You know what just happened. Beast from the Middle East is what just happened. Talking about cloning. Talking about mama. Yeah. Represent. Beast from the Middle East, y'all. Thank you for your time. Peace.